Okay, it looks like we're live. Hi, everybody. Welcome back to the Anarchist Guide to the Universe. It's been a while. I think it's been about 6 months, and we're sorry for the huge hiatus. It just, life kind of gets in the way, and but we're back, and we're really happy. And joining us is Alec Hutchinson, who I have dubbed the Hutch because he needed a nickname. Jason Major.
Hey, everyone.
And then our guest, Gene Mikulka from Talking Space, who was very nice to come and join us.
I appreciate the invite, Rochelle, and I'm all set to talk some space with you guys.
All right, great. And we've got a lot of space news to cover. This year has been very, very exciting. I do want to start the show with giving a very special nod to Gene Cernan, who we lost this year on January 16th. He was the last man to walk on the moon, Apollo 17, and we're losing all of our moonwalkers, but there's still some that are alive, and that's a good thing. But I did want to give a nod to Gene Cernan, who we did lose this year. So today we've got a very full show. I'm going to try to keep everything focused, but it's kind of hard sometimes. And I start to lose information. I'm probably going to look over at my iPad a lot. But today we're going to talk about TRAPPIST-1. We're going to talk about the Pan Moon, which Julia from Twitter has been very sweet to give me some pictures that she has manipulated to show of all the different food and things that people think that Pan looks like. We're going to talk about New Horizons going past flyby MU-69. We're going to talk about some SpaceX news that might or might not turn into us getting into a fight, but we'll see. We are going to talk about EM1, which probably is going to turn into another fight. We're going to talk about Shotwell, talking about Falcon 9 Heavy. Sorry, I got my little list that I wrote down. So yeah, we got a lot to talk about. So again, welcome to everybody who is joining us. So exciting stuff, TRAPPIST-1 and potentially habitable planets. It's about 39 light years away, which is 12 parsecs for us astronomy nerds. And there's three
all of you intergalactic smugglers out there.
Yes.
You Kessel runners.
There are 3 potentially habitable planets. The planets are very close together. You know what? I'm going to put up a picture because I said that I was going to do that. So let me do that. Jason, will you talk while I am trying to figure out how to share this picture?
Oh, well, I've got to figure out what you're showing there at first, but
okay.
I guess we can go into the idea of what's happening in the TRAPPIST-1 system. So there are a confirmed 7 exoplanets orbiting the star TRAPPIST-1. Now, TRAPPIST-1 is the designation of the star itself, and it is an ultra-cool dwarf. It is 12 times less massive than our sun. So what we have here is, okay, so you have the picture up there. So these 7 planets, 3 of which are inside the habitable zone of TRAPPIST-1. All 7 planets appear to be based on mass and density, rocky exoplanets. So that's exciting. And to have 3 of them inside the, whoa, where are we going here? What just happened? Is everything all right? I don't know. Okay, so, well, here we go. So we've got these 3 planets that are potentially habitable out of 7. What's interesting about the TRAPPIST-1 system is all of the all of the exoplanets are orbiting the star in a space that's smaller than the diameter of Mercury's orbit. So it's kind of like a mini solar system, or a miniature version of our solar system, with actually even more rocky worlds, because obviously we have the gas giants, we have the ice giants, and that doesn't seem to be the case around TRAPPIST-1. Instead, we have 7 rocky worlds. So we say potentially habitable, and that's exciting. But we also have to remember not to get too carried away, because as of now, we don't know anything really about these planets other than where they are, what their orbital period is, or what their orbital periods are, and their density. So then, which says that they're rocky. What's their atmosphere like? Is there water in the system? Is there liquid water on these planets? We don't know. So until we get more information, and we'll probably have to wait for the James Webb Space Telescope to take a better look at the system, we're not really going to know what's happening in the TRAPPIST-1 system. But it's definitely a really interesting place to look, because I mean, who knows? If we look at those 3 exoplanets that are within that habitable zone, and we see signatures of water in an atmosphere, well, that's going to tell us a lot. And then who knows, if we start seeing signatures of things like free oxygen in that atmosphere as well, then that could tell us that there's processes on the surface that are creating that, which would of course be life, like here on Earth. So again, it's wishful thinking, but it's a reasonable wish to have at this point.
Yeah, Jason, just to jump in here for a sec, there's an article that a gentleman by the name of Bruce Dormley wrote in Forbes magazine that sort of kind of explores both possibilities of these planets being possibly inhabited and possibly not. One of the things that the article points out is we're talking about radiation possibilities, and the radiation environment essentially disqualifies TRAPPIST-1 from being a habitable area, but then it goes over and says, hey, there may be volcanic activity on a few of these planets, which may go ahead, throw hydrogen and oxygen into the atmospheres, and thus make them possibilities for being habitable. So again, you're absolutely correct. The James Webb Telescope may settle the argument, or put the argument into another direction and cause more arguments. So,
well, undeniably, there's going to be more questions that get posed once we know more. So we don't find answers, we find questions every time we look out there. But yeah, that's a good point. These stars, especially now I know it's an ultra cool dwarf star, or no, I'm sorry, an ultra cool dwarf. And these small stars, these red dwarfs, can be very active as far as what's happening on, with flares and radiation. So yes, even though you can have in miniature a solar system and a habitable zone and rocky exoplanets that are somewhat Earth-sized, all of that, you also can't forget that there is a lot of flare activity coming off of that star, and it also depends on how sporadically energetic that star is. What's the odds of life being able to develop when bursts of energy, bursts of UV radiation, and are getting thrown onto these planets at irregular intervals where life can't somehow evolve or adjust. But again, these are long-reaching questions. They're kind of like jumping over a lot of key points that we need to know first. So speculation is good, because it gets us thinking, and that's the type of questions we need to be asking about exoplanets. So.
Yeah, just as an aside, I recall from the and your audience may recall this. I don't know if they've ever seen the original Cosmos that Dr. Carl Sagan did back in around 1980. There was an episode in there where he returns to his 6th grade class, and he explores ways that we would look for stars around other planets. Back as early as 1980, we didn't know for sure if there were stars around other planets. Today, it's 2017, and in my lifetime, that question's been answered. Mm-hmm. That there are indeed planets around other stars, and some of these might have the ingredients we need for life.
Right.
So,
exoplanets. Exoplanets were still completely in the realm of of reasonable theory, but still, but well, I should say hypothesis. They were still hypothesized up to what, 1992?
Right.
So, that was when we first had a confirmation of, yes, we've observed an exoplanet. It made sense. I mean, the idea of planets around other stars has been a staple of science fiction and then astronomy for a long time. But, it was just imagination until the 90s.
Yeah, and that's what's just stunning. In my lifetime, we're the first generation really to find out that this actually exists. And that to me is kind of exciting. And I was just throwing that out there as an aside. By the way, if anybody's interested, if you go to exoplanets.nasa.gov, they've got a really cool site about the TRAPPIST-1 system. There's some very interesting, travel posters in there. There's actually even a VR of what it would be like to stand on one of the planets. So if anybody, I would encourage folks to go ahead and take a look at that. There's some really cool stuff there that can really educate you about what's going on.
And another place to look to, if you're gonna peek at those too, is there's some nice charts and graphs and infographics at the Planetary Habitability Laboratory out of Arecibo. They keep track of all of these exoplanets. And of course, we have exoplanets that say, Kepler has identified, and exoplanets that Kepler has confirmed. There's also ones that have been spotted through other methods using the telescopes down in Chile with ESO. But PHL watches all that stuff, and they include it in their library and says, hey, here, for example, the new TRAPPIST-1 planets, I want to say maybe all three have been, at least one of them has been added to the catalog of the top 6 or the top 10 potentially habitable exoplanets out there. So every time more are found, they add it to their catalog. It goes into a nice little infographic, and then they show what the size comparison is, say with Earth, Neptune, Jupiter, and our solar system compared to theirs. So that's a great resource. Look up PHL at Arecibo.
Just an aside too, one more reason to keep that place open.
Oh yeah, most definitely.
One more reason to keep that place open. I mean,
Arecibo is an amazing facility.
Exactly,
Yes,
and if we lose that, it's just going to be a bad day.
For the sheer fact that they're one of our best resources for radar observation on near-Earth asteroids in our own solar system. I mean, they're watching space rocks that pass closer than the moon,
right?
And finding out what their orbits are and what their shape and rotation is. So I mean, they're partnering up with the capabilities of NASA's Goldstone facility out in California. They bounce radar off these things and they catch it down in Puerto Rico. That's incredible.
Yep. And again, I hope somebody from NSF is listening, because we really need to keep that place open.
Rochelle, you're muted.
I hopped over to YouTube to see if anybody had any questions. Okay, so we're very excited about TRAPPIST-1. It's going to be very exciting. Oh, K2, Kepler is going to be investigating it as well. I mean, it's not going to be doing a flyby, but it's going to be taking pictures, and we're going to be getting some more information from K2 as well, which is going to be great. I'm glad to see that little guy with 2 GIMP legs still out there working.
Yeah, I mean,
it should have been dead long ago, and it's still going. I think it's awesome.
Well, that just shows the incredible ingenuity of the engineers on the mission, that they figure out how they can get this, this lame spacecraft to keep operating and doing what it needs to do. I mean, there's brilliance there that, they just didn't throw their hands up in the air and go, oh, well, it's broken, it doesn't work.
No,
they figured out something they can do with it.
I actually read a story on it, and they really did all they could to try to save Kepler from just being space trash again.
Mm-hmm.
So, I mean, I've got so much out there already. I'm just glad that they're able to save it.
That's kind of one of the capabilities you miss with the shuttle, repairing on-orbit spacecraft readily.
Right, but even Kepler's too far out. I mean,
you can't do that with Kepler.
With spacecraft in low Earth orbit,
Right.
and so forth.
Well, to throw something out there, I believe there are companies out there right now exploring different methods of on-orbit repair robotically. I know Orbital ATK is doing some things, and I know DARPA is doing some things. So look for that to happen in the not too distant future.
And to add to that, not robotically, but Dream Chase. I had heard that Dream Chaser was tossed around for potentially doing a Hubble servicing mission in the future.
Correct.
If approved.
Correct. And
Really?
Yeah,
Wow.
that's correct. They're talking about possibly having a piloted version of Dream Chaser go up there and do a shuttle style servicing mission for HST. So we'll see how that goes. I mean, my personal opinion is let's just get the commercial cargo version of that up and going, and we'll see how it performs.
And Dream Chaser is at Armstrong right now. So
that's correct. They're getting
shout out to my favorite little NASA facility here in California, which by the way is 80 degrees here. Just
Shut
out there.
Nobody on the East Coast needs to hear that baloney.
Yeah, just to fill people in, we're here on the eastern seaboard of the U.S. We're about ready to get pummeled on Tuesday with a major winter storm, anywhere between 12 to 18 inches worth of snow. For Jason's up over in Rhode Island, and I'm over in Jersey, so we're kind of bracing for impact, as it were.
My back can't handle it.
But Rochelle, to add something, yeah, you're absolutely correct. Dream Chaser's getting ready to restart drop tests for the commercial cargo program, and hopefully by 2019 under CRS-2 we'll see that thing flying.
Yeah, and I know that Dream Chaser is going to be at Armstrong until 2018.
Yep.
So it's going to be there for a while. Hoping to get a trip out there to see it and bring the footage to you guys so you guys can see it as well. I know we're looking at, just to bring up really quick, JPL is having an open house on the 20th and the 21st of May. And Alec and I were lucky enough to get tickets and putting together a little mini tweet up. I'm still trying to convince Jason to come fly out here so we can have a space weekend. But yeah, so we're going to get to go to JPL, and I'll be bringing you live footage from there. And then on the 22nd, we're going to be going out to Edwards. And so I'll be able to bring some live feed for that as well. So that would be cool. It'd be nice to get back to Armstrong. I've missed it out there. It's my favorite facility, and it'll always be close to my heart. And I do want to give a shout out to Jerry Stokes, who went with me to the California Science Center a couple weeks ago, and I got to see my first space shuttle in person for the first time, and it was an emotional and awesome experience. And so I wore my little Endeavour space shuttle in honor of that. Okay, so on to the next really cool thing, which is the moon pan. And the moon pan seemed to be just making my Twitter explode with funny little pictures and food. And I mean,
well, it looks like a ravioli.
It does not. It looks it looks like a head of cabbage to me.
I don't see the cabbage.
I just want to add that pan was not the first space vegetable. Phobos and Deimos were.
First space vegetable that's made out of ice.
I think the most creative one I've seen was out of a Star Trek episode. There was some little critter that attached itself to the
yeah, Alex Parker put that up.
Yes,
and that was spot on. I don't even know how he remembered that, but
yeah, I think that's the most creative one.
I'm going to share some pictures. Let me get the screen share back up. Give me a second. From my friend Julia. and I thought she did some very creative work. This was my favorite one. Can you guys see it?
What do we got? Oh,
Not
yep.
quite
Okay,
yet.
there's the cabbage.
That's
I
nice.
get it now.
Oh, okay. It took a little bit.
The next one, Peter Pan.
Oh, cute. Yep. Pan with pan with pan.
Isn't that adorable? And then I asked her to put it on top of some ice cream.
Sure. Some Baskin Robbins, just
The
empanadas.
pierogi.
Empanadas.
Oh, is that an empanada? Oh, okay. Some people are saying
Is that
pierogi.
empanadas or pierogies? I'm not sure. And there's the ravioli.
There's the ravioli.
That's more my neck of the woods.
Oh, and there's the moon pan.
There's pan.
And it's the A-ring. And I confirmed. For some reason, I was thinking that it was causing disturbance in the rings, but not enough to even make a difference, right, Jason?
Well, okay, so pan.
Talk to us about that.
So Pan's about a 20-ish mile wide moon, and it orbits Saturn inside the Anki Gap, which is about 200 miles wide, and it's a clear spot, or relatively clear spot inside the A ring. Now there is a ringlet that Pan shares its orbit with, but it kind of like alternates. So there's like this horseshoe-shaped, kind of wobbly, very thin ringlet that's on the opposite side of Saturn. So Pan goes around, and this ringlet comes around. So it's, there's all these orbital resonances that hold everything in place. And there is a little bit of a disturbance on the edge of the Enki Gap. It's really more of a how should I describe it? It's almost like if you were to watch it in a time lapse, it'd be very fine rings that would, or miniature ring shadows that would expand out into the edges of the Enki Gap, and that's from the gravitational push of Pan as it goes around. But it doesn't have that same type of dramatic effect that you see in a moon like Daphnis, which is a little smaller, but it orbits in a much narrower gap, so it kicks up that ring material a lot more. So for the most part, Pan's pretty, it's got a pretty smooth sailing through the Yankee Gap as it goes around Saturn. And it was just this past week that we got our best pictures, as Cassini made a 15,000 mile close pass of Pan and showed us the detail of that really interesting equatorial ridge or flange that runs around its equator, and that flange is basically a several mile high buildup of icy material from the gap itself that it's attracted and with its gravity and smashed together and basically just form this giant stalagmite of ice that it's like a skirt. It's really cool. It's super cool. There's only one other moon that has anything like it, and that's Atlas. And Cassini's going to take a look at that next month. So who knows? There might be Pan might have a twin sister with Atlas.
That would be really neat.
Jason, is that a true division? Because I remember during the Voyager missions, they were going to fly one of the Voyager spacecraft through the Cassini division, and with 2020 hindsight, they were actually thankful they didn't, because that really is not a division at all. There's still a lot of stuff in there.
Yeah, you wouldn't want to fly a spacecraft through that.
Yeah, the division that the Shepherd moon, and that's what Pan is. It's a Shepherd moon. It's kind of sort of making sure that the rings are still in pretty good shape. Is that really a true blank division, or is there still dust and stuff in that?
Well, yeah, division? I mean, there's still dust in there because that's what's helped build up that over 100 million years, and by the way, that's about how long some of the most extreme hypotheses place these smaller moons of Saturn, as opposed to, say, on the realm of like billions of years. So over the last 100 million years, Pan has scooped up a lot of that material, but there is still stuff inside the Yankee Gap. And like I said, there is a ringlet that orbits along with Pan in
Right.
Pan's track, but it just happens to be on the other side of Saturn. So if Pan's here, that ringlet's going to be here, and it's kind of a very long horseshoe-shaped segment of an arc that goes around. So if you were to wait long enough in one spot, you watch Pan go by, and within a couple hours, here comes the rest of this ringlet that follows along. So there's definitely stuff there, and you wouldn't want to risk a $1 billion spaceship by flying it through there.
Yeah, again, thanks for the clarification. That's what I thought was going on, so I appreciate it. And just Rochelle, forgive me, the Julia you're talking about, is that our dear another friend that I think we mutually have, Julia Koleski, I think her name is?
It is.
Yeah, she's just to give her a plug real fast. She also does a YouTube video blog for astronomy. So if anybody's
I was gonna, yeah. Thank
Sorry.
You. No. I was gonna do it at the end, but no, I'm glad you're doing it now.
Yeah, I just wanted to get that.
She's amazing.
Yeah, she's
and I
awesome.
love her.
She's incredible. I've seen some of her work, and she does it with a lot of style and a lot of humor. And if anybody's interested, go ahead and take a look at some of the stuff that she's created.
Yes, absolutely. And we love you, Julia. Hi. Okay, so
I mean, if I could just, can I show something here for a minute?
Yeah.
Yeah, by all means, please.
No, hold on, because I want to. Let's see. I'll just show it like this. So I'll do my screen share, and where are you? Here you are. So here we see what this is. Here is this is an animated GIF that shows the pictures from Cassini's flyby on March 7th. So this is, and I know we had some fun with the image of Pan, but this is really what it looks like. I mean, this is a crazy looking moon. That, nothing looks like this, not only around Saturn, but anything that we've seen elsewhere in the solar system. So this is a fascinating little world. And again, it's only about 20 to 30 miles wide. So whatever's going on on this moon is happening at a very, very low gravity, yet you still have this. I mean, the moon hasn't even achieved hydrostatic equilibrium, which means it's not round. It's not big enough to hold itself into a round shape. It's otherwise a very irregular shape, but it has that several mile deep flange that runs around its equator. And by all reasonable guesses, that's made out of water ice particles. So I find it interesting, and it looks to be at least several hundred feet thick. So I find it interesting to wonder what the how strong that thing is. If you were standing on Pan, would you be able to bash it through with a hammer? Would it be as hard as rock? I don't know. So I'm just trying to shut down my screen share here. So pardon me.
Hey, Jason, not to interrupt you. What's next up for Cassini? Because I know the mission's ending this year.
Yeah, it's ending in September.
Right.
Which is a total and complete bummer.
Oh yeah. Well, I mean,
Just so sad.
I've been sharing Cassini stuff ever since I even got into the idea of space blogging to begin with. Cassini's been around Saturn since 2004. So to have the mission come to an end is I mean, it's hyperbolic, but it's devastating. It really it is. I don't know, I'm going to miss it so much, just the idea of being able to see amazing things from Saturn on a daily basis. So that's hard. Now, what's coming up next? I do know there's going to be a similar close flyby of Atlas next month. There's a whole timeline of flybys and close passes and far passes and things like that. Right now, Cassini's kind of at a very, I think it's orbiting Saturn at like a 65-degree angle. So it comes in close. It's what they call ring grazing orbits. So it comes in close, goes right along the edges of the rings, and then whips back up high at a high angle to the poles, to the North Pole. So that way it can get a nice view of the northern hemisphere and the North Pole, which right now is nearing midsummer. So there's a lot of illumination there. So we can see the features in the atmosphere at the poles. At the North Pole, because the South Pole is dark. But it's going to keep doing that, and then eventually, when that's done, it's actually going to be doing orbits that take it down inside the rings. So it will be doing that thing that Voyager didn't do. It's going to
Right.
be diving into the gap, past the gap a few times before the end of its mission. So that's going to be really exciting.
That's
First
gonna be
spacecraft ever
very
do that.
exciting.
Yeah, I mean
That's gonna be amazing.
Yeah, I mean, the spacecraft, we've gotten so much out of the spacecraft. It was launched in October 1997, I believe.
Yeah.
And I mean, it's a darn shame to see the mission come to an end, but gosh darn it, it's going to leave behind quite a legacy of information. It rewrote the book on Saturn. And thanks to those images, we've got we'll be looking at Cassini data for decades.
Yeah. Cassini will be the definitive mission on
Absolutely.
Saturn and its moons for a very long time.
That's why it just seems so sad for it to. I mean, I understand why it's ending, but it's at the same time.
Well, let's get into that too. People,
Why
is it ending? Why does it have to end? Well, first of all, it has to end because it's going to be running out of the propellant needed to control its many orbits. Saturn is a complex system. There's a lot of moons, as well as the rings, and then Saturn itself. So what you don't want to have happen is a spacecraft like Cassini run out of fuel. It's no longer able to be controlled, and then it ends up in some sort of a strange looping orbit amongst the moons, and then some 20, 30, 40 years down the line, it crashes into a sensitive moon like Enceladus or Titan, and potentially contaminates a world that we aren't quite sure if there's anything living on those moons. We don't know that, but we don't know there isn't. So you don't want to contaminate those moons with a terrestrial spacecraft. So in order to avoid that, they're taking the last vestiges of fuel where it's still safe, and they're just going to dive it into Saturn, and Cassini will burn up in Saturn's atmosphere.
Yeah. So it's going to go down in a blaze of glory. Absolutely.
Very much so, yeah.
And it's
sending data back all the way.
Exactly, and that's the thing, is it's going to be sending data back as it's crashing to its death.
Yeah, so we're going to be getting data on Saturn's atmosphere and so on. So again, it is going to be a spectacular end to what is going to be a spectacular mission. And Jason, thanks for bringing up the planetary protection stuff, because that's what I was hoping you'd mention.
Yeah, well, that's an important thing. We, especially Enceladus, where we know it doesn't have an atmosphere per se, so there would be nothing to burn up a spacecraft on entry. I shouldn't say re-entry, but on entry. But it has a thin crust and a subsurface ocean, so you don't want to be dropping a spacecraft down, even one that's been flying, exposed to the radiation of space and Saturn for all of this time. You still don't want to crash something into it. And the same thing with Europa, with Jupiter as well. So the best place to put those spacecraft at the end of the mission, unfortunately, is to just dive them right into the planet itself.
Yep.
But that raises a question for me, and maybe you can help me with this one, Jason, maybe even Gene. Basically crashing into the planet, wouldn't that potentially be contaminating it? At the temperatures
that'll be generated by a spacecraft traveling as fast as Cassini will be on reentry, it's pretty much sterilizing.
Yep.
Oh, interesting.
Yep.
Okay.
And I do think it's worth bringing up Europa Clipper. The next big outer planet mission.
Yeah, that was officially named Europa Clipper this week. That's what it was euphemistically called. It's set to go, and it's still in the planning stages, but we'll just see how this mission develops. I know it has a lot of congressional oomph behind it. It has a lot of bipartisan support behind it, which is important. So we'll just have to watch and see how this develops. But I actually think that mission is going to fly.
Yep. And as of now, would be using an SLS Block 1B launcher, so it could do a direct injection as opposed to flybys and a much longer flight time to Jupiter.
Thus, the need, in my opinion, anyway, that I know there are other alternatives, and everybody's going to be throwing them in my face. But thus, the need for such a vehicle.
I would agree.
We'll get into that later.
Yes, I was just going to say, we'll get into that later. We have to get into that one later. We got to save that one.
Oh boy.
Oh boy.
And the fur will fly.
And the fur will fly. Okay. So crossing off my list here. And the next thing we've got is New Horizons doing a flyby of MU-69 or 2014 MU-69. And the one thing I don't know about, and I meant to ask this question, is why did they choose MU-69? Jason, do you know by any chance?
Because it was there.
I think it gave it I think it was because I think it was a fuel question.
Yeah.
And a trajectory question, and this was just right in the path. It was one of the most it was the most reachable target in that particular trajectory that was going there, and I think that's one of the reasons why it was chosen.
And I will say that let me see if I could do this without messing it up. It is the only object that will be how did they word it? Basically, they're going to go fly by it, and it was picked after New Horizons launched. So in other words, it didn't launch to go see MU-69.
No, that's correct.
And it was discovered after New Horizons launched.
Right. In fact, I believe, if Jason, correct me if I'm wrong, I believe that there were 6 targets that the Hubble Space Telescope had found, and during the flyby of Pluto, they were trying to kick those around what the potential follow-up mission was going to be. They really didn't know even that night if they were going to do a follow-up mission or not, or if the money was there for a follow-up mission. But they had 6 targets in mind, and out of those 6, just the one that they chose was favored because of the way the trajectory fell into line.
Yeah, and I believe that also the timing worked out well too. I mean, within 4 years of one mission, you have a target for the next. And I know we talk about the Kuiper Belt and there's all these objects out there, but still, I mean, everything's very, very far apart. So to have something that you can reach in that time span, you didn't have to wait another 10 years. It was ready to be visited. And they also had the orbital, the trajectory of it down, so it wasn't going to be too much of a surprise. You don't want to guess when you're throwing a spaceship. You don't want to guess when you're throwing a spacecraft at something.
Right, exactly.
That would be very, very dumb.
Now, MU-69 is obviously a lot smaller than Pluto, even though both are classified as Kuiper Belt objects.
I think it's only like 1%, correct, Jason? It's only like maybe 30 miles long. 30 miles in diameter. I'm sorry.
Yeah, I mean, it's like it's something it's something the size of Manhattan, and versus something that's I mean, Pluto is basically planet sized. I'll go there. I'll go there and say
that's because it's a planet.
Well, it makes sense, right?
Oh, here we go.
People keep talking about Planet 9. No, we already discovered Planet 9.
Right.
It's called Pluto.
There's a throwdown going on.
And the fact that the only reason why it's really not a planet is because it hasn't cleared its orbit is just one of the most asinine things I've ever heard in my life. It truly is. And Pluto, to me, will always be a planet. People can disagree with me all they want, but it is still a planet. Go ahead.
Yeah, to kind of back Rochelle up a little bit. There's an interesting. I attended a talk last year at the Northeast Astronomy Forum, and a gentleman by the name of Gerard Van Bell, who is an astronomer at the Lowell Observatory, was present in 2006 at the IAU conference when this whole decision went down. And he gives a rather entertaining look at what that decision was and why it went down the way it did. if anybody wants to look at it, it is available out there on YouTube. I would urge everybody to look at that, because in the end, he says, look, we were astronomers. What the devil were we doing making a decision like this anyway? This should be left up to the planetary community.
Thank you. It should be left up to the planetary scientists. And
Yeah, I mean,
and this is somebody who I love astronomy, but astronomers should not have been left to make that decision. It should have been the planetary scientists. Absolutely.
Yeah, I mean, the he brings up a lot of arguments there too. First off, the decision was made toward the end of the conference, where, you know, like maybe a quarter of the astronomers were still there when the vote really actually happened. So there really wasn't a lot of individuals voting yay or nay. But he basically deconstructs the whole thing and points out that because of the way the planet is defined in this thing, in some cases, Earth isn't even a planet.
Right,
So,
Earth
yeah.
Earth at Pluto's orbital radius would not clear its orbit.
Right. So, yeah,
I'm
and
so glad you brought that up, because think about it. If we were out where Pluto was at, and we would not be called a planet.
Right. So the question there is the definition of planet, should that be contingent on the intrinsic nature of the object itself, or should it be contingent on where it happens to be found? And I make the metaphor of, if a polar bear were to wander several thousand miles south and be found in Mexico, would it still be a polar bear, or would you have to refer to it as something else because it's not found near the pole? Obviously, it still is a polar bear.
Still a
you know,
polar bear.
so there's
good.
you know, it is what it is, regardless
I like
of
that
where
analogy.
it is.
In one of the pieces about, you know, defining planets using in terms of body specific characteristics rather than location, you know, the moon might be considered a planet by those definitions.
Well, and planetary scientists,
Uh-huh.
you know, that may be where you cross this fault line. But planetary scientists do consider objects like the moon and other moons planets.
Well,
So they do have this
yeah.
broad definition. In fact, one of and that brings up a point that came up a couple weeks back. And I know principal investigator for New Horizons, Alan Stern, and some of his partners were issuing a formal reclassification of planets, you know, to the IAU. There was a short paper that was written up saying that these are what we believe the points should be, and none of them have to do with where the object is found in orbit around its host star. In fact, it doesn't even matter if it's orbiting a star. So by their new definition, there would be in our solar system about 110 known planets, with room for more. So
just really quick, which brings up an argument that I've been seeing on Twitter being brought up, is that, okay, well then how are we going to remember the name of all these planets? Well, do you remember all the names of all the stars? Do you remember all the names of all, you know, we'll have our main nine of the whole anything. So there's billions and billions of stars out there. Do you know all the names of those? They're still stars. So we'll have our main nine, and then we'll have other planets, and they'll have they'll have their names, but we'll still have our main 9 planets that we will know the names of. And if you decide you want to learn all 2,000, planets, or dwarf planets, so be it.
Yeah, but feel free. There are 88 constellations. Ask your average person to name any of them, right. And then do they know all of them?
Exactly.
There's
88.
Yes,
I mean, they're all named. They're all constellations. Get over it. And by the way, on YouTube in the chat room, people are pro Pluto. So
Well, that's good. You know, and I've personally been on both sides of this. I've seen the points of both arguments, but at this point now, I've landed myself squarely in the pro-planet realm, the pro-planet camp. I think it makes sense, or at least it only makes sense to, if you're looking for the definition of something, go to the people who are professionals at studying said things. You know, if you were to go out into the jungle and you discover a new species of snake, you don't just, you know, you'll call a herpetologist. You won't just refer to a biologist, even though both study life sciences and living organisms. One is going to be more specialized in exactly what that object is, what that animal is, and they may come back and say, hey, you know what? It's actually not a snake at all. It's a limbless skink or something like that. You know, that we do know about, but I'm going to defer to their professional judgment on that. So astronomers study stars and the cosmos and galaxies and nebulae and all of these things that are happening, but planetary scientists focus day in and day out on the nature of planets and the nature of worlds. So once you leave that realm of being, once you leave that realm of converting hydrogen into helium, it's really the world of the planetary scientists.
Yeah, that's the point that Gerard Van Bell was making. He was saying, he went into this thing saying, look, I'm not on any side of this particular fence. And, you know, even he does work for the little observatory, but he basically said, look, I'm neutral. I'm just giving what my interpretation of what occurred during the 2006 IAU conference as far as what happened and how this whole decision got made. And he really does give a compelling argument for and against. So if anybody wants to go ahead and take a look at that, again, I would really encourage folks to do that. It's out there on YouTube. Just look up Gerard Van Bell, NEAF Talks, and it was put out there last August. So enjoy.
That's NEAF, NEAF, correct?
That's correct. And if anybody's interested here on the East Coast, it's going to happen again toward the beginning of April. So take a look at that. I believe the Rockland Astronomy Club puts that out over in Rockland, New York. So if anybody's interested in coming over and taking a look at that, there's some really exciting stuff going on. They're going to have some really good guest speakers. So I would encourage folks to come on down and to the Rockland Community College and enjoy the event. It's going to be quite a compelling show.
And just to let you know that the flyby of MU69 is going to happen it's between 2017 and 2018. So we're going to be looking somewhere about
January 1, 2019.
Yes.
Yep.
19.
Yep. 2019, New Year's Day.
Me and
Yep.
Dave, I swear, I knew it was New Year's.
Now, you know, we won't see. Let's see, at that distance,
right.
we won't see
It's
data
gonna be,
back for how long? I mean, we're probably looking at.
Don't.
Well, I mean, when you look at it this way, I mean, shoot, when we flew by Pluto, it took how long for all of that data to come back?
Oh yeah, a year and a half.
Yeah, I mean, we got back all of that data from the onboard hard drive. What was it, in October?
But how amazing! I mean, I know it was a long way, but how amazing was that? That first image, seeing Pluto, when all we saw was pixels. I mean, you know how much I love Hubble, but seeing pixels from Hubble, it was amazing.
Just to share something really quick, just as another aside. I'm sorry, but here we go. I was down there for the flyby, doing doing my thing for Talking Space, and one of the things I will never forget is we only had one image up there, and that was the preliminary image that was sent back by New Horizons. And three of the chief scientists were kind of talking to us about it, and actually turned into a session when they were literally arguing over what they were seeing. And then we were chiming in, arguing, say, hey, did you see this? So what turned out to be really a Q&A with all these planetary scientists turned out to be really a moment in planetary geology for all of us. We were sort of all of us were sort of participating in that event, and it was just. Right now, the hair on the back of my neck is standing up just thinking about that. And we were all saying too, if this is the only image we got back, we would still consider the mission a success.
That is pretty. That's actually a very powerful statement. I like that.
Yeah.
Well, and obviously we know how successful New Horizons has been. So.
It's a tough little spacecraft. I mean,
tough little spacecraft, and I think it's going to go and they're funded until I think 2030, if I can remember correctly.
I think that's when that's about how powerful that's how much the RTG can give you,
right.
As far as power is concerned. Whether they're funded that out to that route is another question, but it could still. I'm not.
Don't quote me on that. Like I said, I'm not 100% positive.
Yeah,
it can go until 2030.
Right. That's the what the radioisotope thermonuclear generator gives you on board that spacecraft. And to think something about the size of a baby grand piano can go ahead and do what this thing has done. I mean, hats off to everybody. The design of the spacecraft was a ingenious design. It was a thermal bottle kind of design, trying to keep all the electronics in there as warm as it possibly could be for that distance. And I remember talking to the designer of the spacecraft saying, I just thought it was just an elegant way of solving a lot of problems that they had. And he was just ecstatic and was really, really thanking me for it.
New Horizons isn't one of the Discovery programs, is it?
No,
I think it is. No, it's
New Frontiers.
New Frontiers, okay.
It's with Juno and OSIRIS-REx.
Okay.
And to think that, and to think that spacecraft went through how many iterations before it actually flew? I mean, we were talking about, and this whole thing was just sort of inspired by a postage stamp.
Yeah.
And the idea that that this it brings together these large groups located across the country. You have Johns Hopkins University's Applied Physics Laboratory in Maryland. You have the Southwest Research Institute in Colorado, and of course NASA. You have the Ball spacecraft designs. I mean, all of these groups employ hundreds of people who are all experts in their field to make this one mission happen. It's not just NASA going launch that, we want to know something. I mean, there is some of that because that's where their funding is coming from. But then all of these groups are springing into action. So again, the idea that money invested in space is really money that's invested right here in our country.
Just another indication of your less than half a penny going to some good science.
Yeah,
half a penny.
That's something I'd heard.
Half a freaking penny, and people
less than half a penny.
Yeah.
We don't build the spacecraft on the moon, yet. So
right.
Which
that's coming. We'll get there.
One day, but not yet.
It's. I think it's closer than we thought.
Mm-hmm.
I do.
Well, if Elon has anything to do with it, he's going to be, sending some folks around there. In just about a year and a half, right? Easy, right?
Right.
What's that, Gene? Do you have something to say about that?
I want to
this just in.
Yes. I thought NASA's response to that was rather measured. If you recall, if anybody remembers what the response to that was,
it was pretty terse.
It was congratulating them, saying, we're saying, yes, congratulations, good luck. But by the way, we still want to see, we're still in this for commercial crew and commercial cargo. Remember that, folks?
Remember your contract?
Yes, remember the contract that we're paying, that the U.S. taxpayer is paying for to get crew to the International Space Station. It was essentially saying, hey, SpaceX, we do appreciate you wanting to do other things and you wanting to go ahead and extend this out further. But you know something? Keep your eye on the ball. We know what's going on with commercial cargo and commercial crew, especially commercial crew. We know that Dragon is kind of having its growing pains along with CST 100. But you know something? You might want to go ahead and make sure that Dragon's doing okay first, or Dragon 2 or Crew Dragon, whatever they're calling it now. You might want to make sure that we can deliver crew to the International Space Station first before you go ahead and start paying customers to go around the moon a couple of times and come back. And I think that's what NASA was trying to say. They're saying, look, okay, we understand what you're trying to do. We understand what you're trying to get out there. Great, more power to you, but keep your eyes on the ball.
And even if you look at the mission in a vacuum, you know, Falcon Heavy needs to fly, Dragon B2 needs to fly.
Well,
There's
not
a lot
only
of
that,
milestones that need to be,
and any major
passed.
delay.
You still have to work out it. You still have to work out the trajectories. You still have to go ahead and do a lot of all that. And how much planning goes into a lunar mission? You know, and SpaceX, with all due respect, I love them dearly. Don't get me wrong. I want them to succeed in what they're doing.
We all do, but
yeah.
My question is how much is too much?
That's exactly what I was getting at.
I mean, you get to the point where, okay, we say we're going to do all of this, and we're still trying to get Falcon 9 Heavy completed in the air, which was supposed to fly in 2012.
That's correct.
Go
ahead. I'm
not
sorry.
only that, but you know, Dragon B2 hasn't flown with crew or without crew yet,
right?
At all, in low Earth orbit, let alone beyond Earth orbit. When
does it stop being, okay, this is what we're going to do, to, okay, this is our wish list?
I feel like
we're just gonna keep saying, oh, we're gonna do this, we're gonna do this, we're gonna do this, and they're not delivering.
I would feel better about it had they not tacked on the 2018 date. Had it been 2020,
I'm with you on that, Alec.
Had it been 2020 or further, I would feel much better about that ambition, because then that would put it well past ISS flights with crew and with cargo and Falcon Heavy's debut and so forth.
Yeah, Alec, I have to agree with you there. I mean, you need to go ahead and plan this thing out. You need to go ahead and do a lot of things. You still have a lot of milestones. Heck, but you're so far behind as it is now with trying to get this thing to fly as it is with crew. So why don't you go ahead and concentrate on getting this thing to the ISS first,
right?
Going ahead and making sure that it can do that safely, and then try to extend it out further. The other thing too is, how much resources do you have, as Rochelle was pointing out? You know, SpaceX, I love them dearly, but again, they're not Boeing, they're not Lockheed, they're not, hey doggy, they're not you know, they have a tendency, I think, and to bite off a little bit more than they can chew, and it sometimes make promises that their resources just are incapable of keeping.
Well, I have to wonder sometimes, and I don't tend to wax conspiratorial. I really don't, because I don't like it. But I have to wonder how deep this particular rabbit hole goes. We all know that Elon has, you know, initially right after Donald Trump became president, he was meeting with him in his office, as far as, you know, with a bunch of other tech people, and then shortly thereafter came back. And I remember at one point, you know, it was within the next day or two, he just sends out this one lonely tweet that just said sigh. And I have to wonder how much of this is just, you know, is he being pressured by the new administration to help manufacture a new space race, to put the, you know, to put the pressure on NASA, or to put the pressure on other companies to, you know, or to maybe make something happen just through sheer force of competition? And yes, competition can be healthy, and they are private companies. But how much of it is being, you know, kind of nudged along now by the current administration, which we know loves the idea of competition, you know, even if in just a pure capitalist sense. So I don't know how much of it is, you know, goes deeper than just the idea of we're promising the moon. Sorry for the bad pun there, but really, I mean, what's going on? What's going on on the backside? I don't know.
I could buy that to a degree, Jason. The reason why is you've got a company with finite resources like SpaceX, right? And then you have NASA, who essentially has really the full faith and credit of the United States government and all the resources behind that. So I'm not too sure we're talking about a race here. I mean, the timing to me was interesting because before that announcement occurred, NASA had announced that they're sort of tinkering and going to do a study, and this was based on the information that a recommendation that came out of, you mentioned the Trump administration, that came out of the NASA landing team, and they discussed it apparently with acting administrator Robert Lightfoot, and Lightfoot basically directed Bill Gerstenmaier to take a look at the possibility of flying crew on the first SLS mission. Now, to put this into perspective, this is not unprecedented. It happened for STS-1. The only reason why it happened for STS-1 is because you had to fly it that way. But by the same token, too, I'm not sure. I'm sort of on the fence with this. Yeah, it would be nice to see crew on EM1, but I think you could probably do a lot more with Orion on that first mission without crew. You could really, really push it. You could really, really put it through its paces. Jason, you were there for EFT1 with me.
I sat right next to you when we watched the return. When the video feed was coming in. Yep. Right.
Exactly. And so darn well how successful that mission was. I mean, I think they only missed 3 points out of the 78 that they had to go ahead and tackle. And one of them was a minor thruster issue. The other one was that the inflatable balloons on landing didn't inflate properly, and it didn't matter anyway since the thing landed in stable 1 or right side up anyway. But those balloons, for those people who aren't familiar with Apollo, are used to inflate just in case the spacecraft lands in a state, what they call stable 2, which would be like on its side and it's kind of floating and bobbing. This thing is basically to right the spacecraft up, and that was really the only points of failure that mission had. So I think it gave them a lot of confidence to try to go with this forward. The other thing too that Bill Gerstenmaier said, because it was on the line during the talk for this. He said that it kind of gives us an opportunity to step back and kind of understand what exactly we are doing from a spacecraft standpoint, to make sure that we have all our I's dotted, all our T's crossed, to understand exactly, to make sure that we're doing this the right way. And I think too that this kind of study, even though we may not go down this path, would avoid a lot of problems going forward. I mean, as it is now, I think EM1 has got the couches put in for crew simulant mannequins or dummies that are just basically going to be lined up for with dosimeters to see how much radiation that a human being was going to take inside the spacecraft. But if I recall too, there's still work if you decide to throw crew into this thing. There's still work that needs to be done inside Orion to go ahead and put those in there, and a lot of the stuff that's in there now would have to be pulled out, reset, redone, and put back in. Like, for instance, the life support system that's come under, saying, well, you've never flown this thing with a life support system before. Well, the life support system really has been flying on ISS now for 3 years. So there may not be a problem with actually testing the life support system. There's going to be a delay in getting it installed in Orion, because you have to pull out all the stuff and then install the life support system and then reinstall everything. So what the game plan is, they're going to look at the feasibility of this thing, try to find out if it is feasible. The other thing too that Bill Gerstenmaier warned is that we don't want to go further than 2019 on this, because we go further out from 2019, we might as well fly EM1 the way it is now anyway. So but again, this is going to be kind of a way to step back, understand what we're doing, and really make sure that we've got the spacecraft we want to make sure that we fly and fly well.
Okay. To address a few points.
Go ahead, Al.
I know STS-1 was invoked as a comparison. Although I do want to note that there are some notable differences in that in STS-1, we had never flown a side-mounted vehicle like that with no launch escape system.
Right.
No ejection seats, but I think that was much more dodgy than...
well, the ejection seats, Alec, were problematic anyway. I mean, even Young and Crippen knew that.
Yeah.
Because if you hit those things, there was more likely the odds were that you were going to end up splattered on one of the OMS pods. So it was, I mean, they actually even took those later on after the 4 test flights. They actually removed them, and that was on the request of the pilot and the co-pilot anyway, because the idea was, you know, we can punch out, but the rest of the crew can't. No, I'm not going to
leaving people in the lower decks.
No, we're not going to do that.
And also, abort options are severely limited. You know, you got, RTLS and TAL and so forth, but RTLS is
that's a dicey maneuver, and you know, I'm thanking God we never.
And it requires something short of just the vehicle, of total loss of vehicle instantaneously.
Yeah, I mean that was the RTLS maneuver was kind of dicey on shuttle, but to just to move away from shuttle, I know that was kind of, you know, invoked on, you know, but here's the deal. It was done because it was not. What I'm saying is it wasn't unprecedented. We did STS-1 like that because we had no choice.
I think that Apollo 8 would be another good one, because despite the fact that the Saturn V had flown twice beforehand, there were some severe problems on Apollo 6, which was the last.
Right, the pogo issues.
Yeah, and
go ahead, I'm sorry.
And we flew the first ever mission with crew on a lunar orbital mission on a rocket that had not flown flawlessly for either of its test flights without any astronauts on board.
Yeah, but after that, it flew. You know,
after that, I mean, the Saturn V had there were issues, but there were no catastrophic issues going forward.
Yeah, I mean, you still have the Saturn engine going out on Apollo 13 and a couple other things, but you just, you know, there were other little things, but again, you pay your money, you take chances.
Yeah, I mean, spaceflight isn't an endeavor where you can go in without risk. You want to mitigate it as much as possible, but you'll never completely eliminate it.
Right, and that's something that, you know, I mean, we know that there's calculated risk on every flight, but you want to mitigate as much risk as you possibly can, and then go forward.
It's weighing cost benefit and exactly how risky a given mission is, especially when you've got dealing with astronauts.
Yeah, I mean, when you're dealing with individuals' lives, it's a whole different ballgame, and you want to make sure that you've got a bulletproof spacecraft, or at least as bulletproof as you can possibly make it.
And Orion would have, you know, at the very least, it would fly with an active launch escape system.
Right. And that's something they still need to work out too. There's still, I believe, there's a pad abort test or something like that.
Currently, there's another abort test scheduled that would be after EM1 if they fly it without if
Right.
If they decided that they could do it and they got the money to do it, fly EM1 with crew in 2019, then they would shuffle the dates for that around so that the abort test came first.
You know, just to point out too, they did do a test out in Yuma, Arizona this past week, I think it was, for the parachutes, and that went pretty darn well. So
yeah, they threw an engineering model with the parachutes out, and it as far as I know, it was a flawless test.
Yep. So, you know, but again, you want to make sure too that things are bulletproof, and you want to make sure that you've got the best spacecraft you can. So I think too, no matter what happens with this study, it's still going to go ahead and give you a good opportunity to step back, figure out what you're doing, take a good look, making sure that you're doing everything the right way, and then plow forward.
And the notable difference differences between a crew, a profile with crew and a profile without would be with crew, it would be a free return flyby.
Right.
That's it.
Right.
Without crew, I think it would spend 2/3 of a month in orbit around the moon.
Right. It's a 3-week mission without crew,
and it would be a much a stress test for the vehicle. In which, if they did it without crew, that would allow that. Yeah, I mean, it's not like it's that's not a clear plus minus situation. There are words to be said for both sides.
Right, and I don't know. I know we're coming up soon. I believe sometime in April. I want to say the first full week in April. We're coming up on the same span of time between Apollo and Shuttle. So I'm wondering too if that has any bearing on this as well. Yeah. I mean, we don't have commercial crew up and flying yet. We don't have, because of political nonsense, we don't have Orion flying up and flying yet. So I'm wondering if that has anything to play into it as well.
Yeah, if Orion did fly with crew, and if it got the money, and if it was decided that the risk and benefit was favorable, then you could theoretically fly it before the 50th anniversary of Apollo 11 without serious schedule slips. Theoretically. Yeah.
So I think either way, if EM1 flies without crew, it's still a fantastic mission. I think you could still do a lot without it. I think you could still push the spacecraft to its very limit and find out what exactly this thing is capable of doing. And I'm on the fence, but I'm kind of leaning toward unpiloted. That's just me.
The benefit that I had heard regarding flying it with crew would be it allowing for a much more robust EM2,
right?
What they're carrying, and carrying extra pieces. I had even heard that like the first pieces of the cislunar outpost that they had talked about might be included on that mission if they did fly it with crew.
Yeah, I mean NASA's already indicated. There was an article in Space News. I believe it was dated March 10th, if I'm not mistaken. That NASA is indeed, despite the uncertainties that are going on within the policy arena right now, they're going to plow forward with trying to establish a cislunar outpost. Yep. And as you pointed out there, Alec, that's EM2 theoretically could lead to the first components of that going out there, provided we fly with crew with EM1. And we check out the spacecraft piloted. So there are benefits to both sides, but I'm kind of leaning toward unpiloted. The reason why is, again, you can really push that thing, you can push that beast as far as you can, and really, really kind of wring it out and make sure that everything's operational. Mm-hmm. I think we did that with Apollo 4, we did that with Apollo 6. And it kind of, I don't know, it to me it works that way too. So we'll just see what the study. I believe the study is supposed to be in about a month or a month and a half. I don't quote me on that.
I had heard like around the end of March was something around then. So
yeah, so. Rochelle, I guess we'll have to go ahead and reconvene and talk about the results of that study.
Yeah, we will. Absolutely. Me and Jason were just over here drinking my Coke. We'll just let Gene go on his EM1 rant. That was amazing. That was awesome. During this, if anybody watches the replay, you'll see me laughing. I don't mean to. I'm so sorry, but it was just really cool to see Gene passionate about something and go on such a rant. I appreciate that. That was really good. It was finally somebody besides me going on a rant.
I'm passionate about this topic, and so is Alex. So it was kind of fun to talk about that with somebody that is as knowledgeable as I am, that's been watching this as much as I am. Yeah, I respect Alex's position.
Yeah, I had just been to Marshall, so I kind of saw a lot of the SLS test stuff up close. So it's definitely a topic that I enjoy.
I will say this, that I trust Hutch with anything that has to do with rockets, how they work. I'm sorry, Ozzy's playing with his toy.
It's okay. Rochelle, it's all good. I remember if anybody's a long-time listener of Talking Space, if you listen really, really hard in some of the earlier episodes, you might hear a bell ringing. And that was my late Rabbit Oliver playing with his toys off in the distance. So I empathize, Rochelle. It's all good.
I just looked over at him and he looked up at me like,
what happened?
Oh my goodness. Okay, so I will say that I trust whatever Alex says instinctively when it comes to anything that has to do with EM1 and anything with rockets. So whatever Alex says, I'm going to respect and I'm going to back him up no matter what. My personal opinion, I think it'd be great to see it manned. I do.
I would not be opposed to it if the study finds that the risks aren't too high and then the cost benefit is favorable. So
if they, I'm sorry, I didn't mean to cut you off, Alec, but I mean, obviously, if they're going to find issues and it's not going to be safe, then no. But I think that if it's going to go smoothly, which I think NASA is going to be just more very extra careful when it comes to this. If it's going to be manned, I don't think they're going to leave anything to chance. They're not going to. I don't think that there's going to be any mistakes. I mean, I could be wrong, but I think that they've learned from the mistakes of the past.
And it's worth noting that Orion, a stripped down version of Orion, has flown in EFT1, so it's not complete. It's not. Some of the hardware has been flown and tested, and of course all the tests here on Earth with parachutes and water drop tests and so forth. So.
Yeah, I mean, again, I'll just to chime in, I'm kind of leaning toward unpiloted, but if we fly piloted, I don't have a problem with that either. I think either way, I think we're going to have a good, robust spacecraft, and that's all I want. I want to make sure that, I mean, we had a really great start, as Jason would agree with me, with the FT1, and I just want to build on the success of that particular mission. The whole logic though of trying to do this within the time period though is to make sure that we don't kind of bump into the timeline for EM2 as well, because there was some thought too about accelerating EM2, and when they said that ain't such a hot idea, they said, well, let's try to see if we can combine the mission objectives of EM1 and EM2. So we'll see what the study brings, and if whatever the decision is, we'll disrespect it and move on.
Right.
Just as an aside related to SLS, I do think that it needs a proper name. At some point.
Yeah, there's actually somebody out there. I think there was a move at one point to try to get some grade school students to go ahead and name the rocket, and I don't know where that went. That's something that I'd like to follow up. Somebody in NASA knows what's going on with that.
Yeah, I mean, SLS works as a designator, like STS for the space shuttle, but I think that people would be. I don't know. I feel like there might be a little more warmth towards it if it had, if there was a little more personality involved. I mean, on a superficial level.
You can always adopt the old constellation name.
Yeah, well, Ares 5 or Ares 6.
Yes. Yeah. I am all about adopting the old constellation name. That you just piqued my interest.
Yeah. It's SLS kind of reminds me of the Ares 4 concept, where it combined the upper stage of Ares 1 and the lower stage of Ares 5. It's obviously a different rocket, but
yeah, it is.
Yeah.
Oh, I do. Gavin Price, who is my friend from Wales. Hi, Gavin. I hope he's still watching. He sent me a message. He wanted me to ask the panel.
Mm-hmm.
He wanted to know what your views on Rocket Labs and Electron Rocket are.
Oh, the Electron is such a neat little booster. They are also in that small booster kind of category that's destined to fly, CubeSats and small payloads. We need vehicles like that because that's what a lot of individuals at Satellite 2017, which I guess it just ended this past week. It's a conference for satellite manufacturers. They were saying that for the small sat and CubeSat area, we don't have enough rides going, and vehicles like the aforementioned booster would go ahead and help close that gap and give those small sats a ride that they so desperately need. So yeah, I'm all for them. I mean, the SpaceX once had Falcon 1, which they abandoned, and another company of former SpaceXers got together and started another company called Firefly. They ran into a little bit of an iceberg. They thought they were going to have to disband, but they are back up and running, and with their booster as well. So because they found an investor to save them. And again, this is the small sat or CubeSat variety booster that could go ahead and give folks the ride up there. So yeah, I'm all for, go for it. Go Electron, go Firefly.
Well, while we're still on propulsion, a whole different kind of propulsion, but I had heard that Marshall's still kind of toying around with the nuclear cryogenic propulsion stage to kind of revive NTRs as a future upper stage for SLS.
Yeah.
So that to enable much quicker missions to Mars would be the obvious choice initially, especially when you're dealing with people. You reduce time and space, microgravity exposure, radiation, so forth. So.
And Alec, I'm just going to throw another monkey wrench into that thing. Franklin Diaz's Vasmir engine also, I think, is going to be tested as well at some point.
That's kind of another one that I've heard, kind of in the nuclear family. Not the same as NTR, but it's kind of within that category.
That's the one that runs on magic and unicorn farts.
Well, I mean, if you define magic and unicorn farts by either very large solar panels or a nuclear reactor, then yes. I mean, I guess it needs a massive power source on.
Am I thinking of the same one? Am I thinking of the one that was tested over at Johnson, and it created a very, very negligible thrust with no fuel?
You're
I'm thinking of the EM drive. I'm thinking of the
you're thinking the EM drive.
I'll go back into the world of
that's a whole different boost. That's a whole different engine, and the mythical EM drive. And I'm not even going to go there.
Yeah.
But the Vasmir engine is something that former astronaut Franklin Chang Diaz is working. Him and the Astro group are hard at work at
my apologies. Yeah, my apologies to Chang Diaz, because that actually is some really amazing plasma technology he's working with.
So, I mean,
if you're a disciple of Robert Zubrin, he thinks the whole thing is garbage, but that's Dr. Zubrin. He has his own idea of getting to Mars, which has gone through several iterations since he first developed it in the 1990s.
Isn't he in favor of NTRs for Mars Direct?
Yeah, I mean, Mars Direct has gone through so many iterations.
Yeah, I know it's had a few iterations over the years.
Yeah, I mean, I remember Dr. Zubrin. He was working for Martin Marietta, for God's sake, and that's when it was first put forward at a National Space Society conference. I think it was in either 1993 or 1994. I remember bringing the slide pack back because I remember doing the slide presentation for a group over at the local planetarium here. But it was just, again, that's gone through so many iterations. It's not funny, and I'm just not going to go there.
Yeah.
Are we still talking about that? I just wanted to point out and talk a little
Hi,
bit.
Ozzy.
I mean, New Glenn. We didn't talk about.
Oh, good God! Yeah, I mean,
New
there's
Glenn. How
so,
did we forget that?
there is so much going on in the new booster area.
I know,
It's ridiculous. We
Oh.
have Blue Origin jumping in there with New Glenn. Orbital ATK is announced this week during their quarterly call that they are also looking into a heavy lift capability in conjunction with the U.S. Air Force. They are contracted out to, and with another company as well, competing. But it looks like they are going to go ahead and proceed with part one of the investigation to see if this new booster is actually feasible, and then based on the study toward the end of this year, about December 2017, early January 2018, they'll get the go no go to proceed further. This is based on whether the Air Force likes what Orbital's up to, and if Orbital sees it as sees a firm business case in it. I believe Orbital 2 is looking in at leasing high bay number 4, I think, or number one of the high bays in the vehicle assembly building for construction of this booster, and it would fly off of pad 39B. It's so they've got that's going on. New Glenn is going on. I think Lockheed Martin just announced just a couple of days ago that they're kind of discontinuing a research into a medium-sized booster that they had called the Athena. The game plan there is just to continue flying Atlas V for a little while until Vulcan really gets situated, and then they're just not gonna fly Atlas V anymore. But there is just so much going on out there, and to me that's fantastic. You've got Falcon 9 out there right now. You've got other boosters out there right now that are going through this. You've got Antares from Orbital. You've got the new possibility of a new heavy lift vehicle. You've got Falcon Heavy waiting in the wings. There's just so much new stuff going on with boosters here. We're really going to be giving the world a run for their money as far as getting heavy lift back here and getting boosters back here in the United States. This is an area that we've had, or we used to have, supremacy in, and then we just kind of lost it.
Well,
but now we're getting that back, and that's, to me, is exciting. It spurs off innovation, and the more players in this thing, the less money you're going to spend on getting stuff to low Earth orbit and stuff to space, and that to me is the exciting part.
And speaking about supremacy and heavy lift, you could see some of the old variants of the Saturn V that were planned beyond Apollo. Solid rocket boosters, NERVA, nuclear upper stages, and so forth. Had that been the focus rather than the space shuttle and everything we ultimately ended up focusing on in the 80s and 90s and so forth.
Yeah, well, again, I'm one of the biggest shuttle huggers out there, and I love the vehicle to death. But in a way, it was a double-edged sword. It kept us kind of along the shores, if you will, of the ocean for about almost 30 years. We didn't really intend to fly shuttle as long as we did, but we did, and now we're just trying to make up for lost time. So.
Yeah, the shuttle. We've gotten a lot more experience with long duration flights and low Earth orbit and everything because of it, and it kind of enabling the International Space Station and so forth. So not wasted time, but certainly not the same thing as having an active and an active program for exploring, continuing to explore the moon and Mars and so forth.
Well, it's not wasted. We figured out ways. We figured out ways to build large things in low Earth orbit. So what's to say we can't do that around the moon or Mars or so and so on? So again, this is kind of this is kind of cool stuff.
We could be seeing that happening with, like had been mentioned before, the cislunar space station. Could be I don't think it wouldn't be as big as the ISS, but it would use multiple modules assembled in lunar orbit.
Well, yeah, I mean, shoot, to bring things a little back to bring things back to the commercial area here, you've got not only that, but I think after ISS splashes, you still have Bigelow Aerospace out there with the inflatable. I'm sorry, with the expandable, not inflatables. They get torqued off when you say that. It's with their expandable modules, and you have Orbital ATK that's looking at possible uses of Cygnus for the station. So
you got ULA's cislunar 3000 or 1000.
That's another thing too.
Partnership with Bigelow, which would use BA 330s in lunar orbit using ULA launchers like Vulcan and the ACES upper stage and all that.
Yeah, they're talking about a whole cislunar commerce type thing setting up there. So
where you would be it would be using a lot of technicians and things like that rather than flying small research crews.
Right. There's to invoke the Northeast Astronomy Forum again. A United Launch Alliance representative did talk to that too, and I think that's out there as well. So if anybody's interested, go ahead and take a look for that. It was a very, very engaging talk. I don't the gentleman's name who gave it escapes my brain, but he was quite good at giving a description of what was going on, and I'd really strongly suggest folks take a look at that.
And if we want to go over to recent launches like CRS-10, SpaceX's debut from LC-39A, the most recent resupply mission to the International Space Station off of American soil. Since we had the Progress, I think it was MS-04 flight, just a little bit afterwards.
Yep. And Cygnus is going to be back at it, I believe, March 21st.
Yep. Yeah.
From the Kennedy Space Center at Cape Canaveral, Florida, they will be flying an Atlas V this time, not Antares, to go ahead and just. It has nothing to do with Antares. Antares actually performed exceptionally well during the CRS during the OA5 mission. It actually did well beyond what it was supposed to do as far as lift and so on. So it had nothing to do with Antares. It had more to do with the amount of cargo that's flying on OA7, and just to get the ISS into good logistical shape right now. And to give you an idea too, I think this will be the only Cygnus mission this year. If I recall from the quarterly announcement that was made this past week from Orbital, the next time you'll see Antares fly will be next year, OA8 and OA9. They will be flying out of Wallops on Antares.
And as far as more orbital ATK news is that I believe they're going to have their debut Minotaur 6 launch out of Cape Canaveral this year, I think in July. That'll be the first. That'll be the first of a launch out of that pad. I forget which pad it is. It'll be the first one in a while. That isn't out of either SLC 41, SLC 40, or SLC 30. Is it 37B? I think is what the Delta 4.
Yeah, I think so. Yeah, but that's also kind of exciting, and or even over on Pad 0B over at Wallops, because I believe that's where Laddie was launched, if I'm not mistaken.
Right,
and
right.
And a Minotaur booster did take Laddie to the moon.
Yeah, so that's it's kind of exciting. Minotaur I think had been prior to that had been limited to Vandenberg and Wallops, so now it's coming to CCAFS.
Yeah, I mean, flying Minotaur is kind of interesting. If I recall exactly, Minotaur is a
All solid.
yeah, it's a decommissioned ICBM.
Oh
Actually.
yeah, I think it's I can't remember. I think it was the Minuteman III that it's
Yes, yes, and right, and you need like special permits galore, and waivers because of treaty contracts.
It kind of harkens back to the the Titan family of launchers.
Yeah,
it traces
exactly.
Their lineage back to the Titan II.
Yep. Hail Gemini.
Okay. I think that was it. Was there something that we missed?
Were there any questions that anybody had?
Yeah, Rochelle, if anybody's around, we'll be more than happy to entertain some questions.
Okay, just real quick. Gavin wanted to ask, Skylong and Saber engine, worth pursuing or not?
Yes, unequivocally. We talked to the folks over at, I believe, Reaction Engines on a Talking Space episode. And this is exciting technology. We're talking about an engine that can get you from, I believe, I want to say New York to Tokyo in about 2 hours. That's one thing, but Skylon itself too would be a to fill in the blanks for folks that don't know what Skylon is. Skylon is basically a delivery system similar to what the shuttle was. It would go up, deliver its payload, and then come back down. It is unpiloted though, and it would use the aforementioned engine that Gavin was talking about to go ahead, break the atmosphere, drop off its payload, and return. The neat part about it is you could fly it from any large airport that could accommodate that vehicle. I believe I want to say, I want to say that it could accommodate that you can land the thing pretty much at anything that can accommodate an Airbus 380 or something like that. But you want to go ahead and make sure that this thing can land in, I think, in a airport that could accommodate the spacecraft. And I think they're looking at the an airstrip that they're trying to construct for this thing over in Kourou, French Guiana, that ESA would supervise. But it's really exciting technology. So exciting too, by the way, that not only ESA is pouring money into it, but I believe the United States Air Force is looking at this engine. And they too are kind of throwing some money, I think, at the development of this. So it's intriguing. Yeah, and it's well worth pursuing.
He was very happy that I asked that question.
Woohoo! I hope he liked the reaction.
He was very happy.
And if
just happy faces.
And just to give my own program a plug, we did talk to those folks over at Talking Space. I don't remember what the episode is, but take a look. Gavin, if you want, I will, because you follow me, I will send you that information and get that over to you.
And something that had crossed my mind when you mentioned, it could land at any site big enough to handle like an A380. A different spacecraft or different vehicle, Dream Chaser, I've heard has the ability to land at just about any airport.
That's the exciting thing about the SNC Dream Chaser, where not only that, it uses green fuels. Basically, you're not going to have this phalanx of individuals that you needed with shuttle to come over here and make sure that there was nothing weird, because of the hypergolics that the shuttle used. Which hypergolics meaning two gas compounds, when they come together, they don't like each other, so they go boom. To make sure none of that was kind of off gassing out of the orbiter. You don't need that kind of secure, that kind of stuff anymore with Dream Chaser. So that's another thing too that makes it kind of an exciting vehicle.
I know that when I was in Huntsville, they were kind of talking about it as potentially the next home of Dream Chaser, being Huntsville being one of the main landing sites if it really starts flying in in earnest.
Yeah, I know they're looking at the SLF, but I know too that they're because I believe Space Florida now has the SLF, but
Yeah.
I think too it can land at any
just
very large airport.
Yeah,
I
basically,
mean,
so that any runway that could handle a decent sized passenger jet could probably handle Dream Chaser.
Yeah, so
I could have to look up the specific runway footage, but
so who knows? You might be able to see this thing landing at an airport near you at some point. Who knows? Maybe even over at Newark or JFK at some point.
Hear those sonic booms.
Yep. That'll wake you up.
Yeah, oh yeah.
I miss hearing those. I do.
Oh yeah.
I miss hearing them.
Oh yeah.
They were nice. They were very
yeah.
The only shuttle landing where I was I happened to be on the west coast of Florida was STS-125 when it was landing at the SLF. It kind of goes over the whole Florida. It passes. Yeah. So I didn't have much experience with hearing those when the shuttle was flying.
I think we lost Jason.
Oh no.
Oh no. Okay, so I think that's going to be. There he is.
Well,
no, he's not. Oh, there he is.
I don't want to leave without him. There he goes.
Yes, just enough time for us to say goodnight.
My Google kept dropping out on me, so I had to keep coming back in.
It's okay. I hate to leave our viewers, but we're going to be running into 2 hours here, and pretty sure that Alec and Gene's throats are probably sore and need some water.
Oh,
I'm not used to hearing Alec talk this much, so it's actually really nice. I want to thank everybody for joining us today, and it was a really great show. I love getting riled up about SpaceX. I love talking about the TRAPPIST-1. It was great hearing you guys talk about how passionate you are about these rockets and EM1 and New Glenn and whatever it was that Gavin had asked about, because I have no
Skylon.
idea. I guess I'm going to have to look more into that.
Yeah, Skylon's an incredible vehicle.
Okay, I'm going to have to look into that, and I know I'm going to be researching Dream Chaser a lot as well. So again, thank you to our viewers, because without you, we do not have a show. And we will see you on Twitter, and I always look forward to our conversations every single day. I know that sometimes people will think that they send me too many tweets, or they're worried that they're going to send me repeat stories. Don't worry about that. Send me the stories. Send me what you think that what I would like, because sometimes there's things that I do miss. So keep the conversation going. You guys know how much I love space and astronomy. So with that, I want to thank Gene from Talking Space for joining us today. This is not going to be his last time. He will be on again.
Thank you, Rochelle, for the invite, and it was an honor to talk to you and to the team and to your audience. And
yes.
Just to answer a couple questions I've been getting offhand. Talking Space is in a little bit of a hiatus right now because we have one of our team members that is not doing too well. Sawyer, get better. But as soon as Sawyer gets back into fighting shape, we'll be back on the air and back talking some good space for you. So thanks for your patience. And Rochelle, thank you again for this opportunity. I had a blast tonight. Thanks.
You're welcome. It was wonderful having you back on the show. Alec, it was great hearing you talk this much. We got to have to do a show just on rockets, just so we can hear Alec talk the whole entire time.
Oh yeah.
And Jason, poor Jason, I think he doesn't feel like he's got a choice, that he's got to be on the show. But it's always wonderful having.
I would never choose. I would never choose otherwise.
Thank you, and again, I'll see you guys on Twitter. And I'm going to sign off how I always sign off. And I've missed saying this. Go out, look up, and discover. I'll see you guys later. Bye.